Alright, today's lesson is on independent and dependent events. By the end of this lesson, you should be able to identify the difference between an independent and a dependent event, as well as find the probability of independent and dependent events. So before we talk about that, let's start with a basic definition of probability. What is probability? Well, probability is basically the odds or the chances that some kind of event will happen. We define it mathematically as the probability of an event is the number of successful outcomes, the number of ways something can happen, divided by the total number of outcomes. So that might be more easily explained by an example. Before we get into the example, I want to explain that the probability of something happening is always a percentage between 0%, no chance of something happening, and 100% chance, guaranteed to happen, and anything in between. Remember that a percentage can be written as a decimal, right, between 0 and 1. So the probability of an event will always be a decimal or a fraction between 0 and 1. It cannot be negative. The chances that something happened cannot have a negative. And the chances of something happening can't exceed 1 or 100%. It's not, we don't say that it has a 110% chance of raining today, right? That would make no sense. Take a look at this example here. Given a number cube, what is the probability of rolling a 4? And a number cube is just another way of saying a dice, right? So a dice, right, we're going to figure out how many ways we can roll a 4 and how many total outcomes there are. Well, we can see that the total number of sides on the number cube is 6. There are 6 sides on that dice. Each of them are numbered 1 through 6. Therefore, we have a total number of 6 outcomes. There are 6 possible outcomes when we roll a dice. I can roll any one of the numbers between 1 and 6. However, there is only one 4 on the number cube, so there's only one way to roll a 4. Right? So the total number of successful outcomes is just 1. The total number of outcomes when I roll a dice is 6. So we write that the probability of rolling a 4 is equal to 1 out of 6. That means you got a 1 out of 6 chance of rolling a 4 when you roll a dice. Now let's talk about what an independent and dependent event is. So for events to be independent, right, 2 or more events will have outcomes that don't affect each other at all. So the outcome of one has no influence on the outcome of another. So for example, if I am rolling a dice and then I'm flipping a coin, well, no matter what I roll on the dice, that has no effect, no outcome on what I can flip on my coin. I can still flip a heads or a tails. So those 2 events would be independent. All right, so more examples of that would be like picking a card from a deck and flipping a coin. Right? It doesn't matter what card I pick from the deck. It doesn't influence what I can flip when I flip the coin. So those 2 events are independent. Another one might be picking 2 pairs of socks out of your drawer with replacement. All right, so that's going to be one of your key words to identify when an event is independent or dependent, is if they do it with replacement or without replacement. Because if I pick a sock out of my drawer and then I put the sock back in the drawer, now no memory has been retained. So I have an equal chance of drawing any other sock the same as I did the first time. So those 2 events would be independent of each other. No matter what I pick the first time doesn't influence what I can pick the second time. So let's do a few examples of an independent events and finding their probability. Right, suppose John flips a coin and then rolls a die. Okay, what is the probability that the coin lands on heads and he rolls an even number? All right, so we're flipping a coin and then we're rolling a die, and then we want to find the probability that we flip a heads and then we roll an even number on the die. The way that we figure that out, right, is we first calculate the probability of flipping a heads. So remember, there's only one head on a coin, has 2 sides. One's a head and one's a tail. Only one of them's a head, so there's one successful outcome out of a total of 2 possible outcomes. And so flipping a head on a coin is 1/2. 1 out of 2. All right, so there's the number of heads on the coin, and there's the number of possible outcomes when flipping the coin. Now let's talk about what the probability of rolling an even number on the die is. All right, so if I count how many even numbers there are on the dice, we see that there are the numbers 2, 4, and 6. All right, so that is the number of even numbers on the dice. We know that there are a total number of 6 sides on the dice, so the number of possible outcomes when rolling the dice is 6. So the probability of rolling an even number is 3 out of 6, or 1/2. All right, and in probability, when we have more than one event happening, we want to know the probability of, in this case, flipping a heads and rolling an even number. The word "and" implies multiplication. That's what it means when we're talking about probability. So when you see that word "and" something happening, it means you're going to multiply probabilities. So I'm going to multiply 1/2 times 3/6. I get 3/12, and then I could reduce that to 1/4. So the way that I can interpret that answer is that I got a 1 out of 4 chance, all right, of flipping a heads and then rolling an even number. Let's see if we can find the solution to this probability. A school finds out that out of the 10 students, only 4 like pizza. If the school chooses 2 students at random with replacement, what is the probability that both students like pizza? So as what's happening here is we have 10 students, and we're going to pick 2 of them at random. First, I'm going to pick a student, and then that student's going to rejoin the line, and I'm going to pick another student. So it's possible for me to pick the same student twice. We want to find the probability that both of the students that I pick like pizza. So these smiley faces here represent the number of students that like pizza. And here's the 6 that don't like pizza. And altogether we can see that there are 10 total students. All right, so the first event, I'm going to pick a student. All right, so we can see that there are 4 students that like pizza. So those are my successful outcomes out of a total of 10 students. So there's 4 out of 10 chance that I pick a student that likes pizza. Then that student rejoins the line, right? And I get another 4 out of 10 chance of drawing a student that likes pizza. So now in this case, both of these things are happening. I have to do one and then the other, which means I multiply their probabilities. All right, so to find the probability of events, when it's one event followed by another event, we multiply the probabilities of each individual event. And in this case, we get that there are 16 out of 100 chance, and we reduce that to 4 out of 25. We could also report this probability as a decimal or a percentage. So take a moment to pause the video to see if you can calculate this probability. Johnny is playing marbles with Jane. Johnny has 9 marbles in his bag, and 3 of them are green. Jane has 10 marbles in her bag, and 2 of them are green. What is the probability that Johnny picks a green marble and Jane does not? All right, so one useful tool when you're solving these type of problems is to draw a picture. So I'm going to draw that out for you. So here's a picture of the bag of marbles that Johnny has, and here's a picture of the bag of marbles that Jane has. See if you can use that to calculate the probability that Johnny picks a green marble from his bag, and then Jane reaches into her bag and she doesn't pick a green marble. All right, so you should have been trying to calculate the probabilities individually and then multiply them to find out the probability of one event and then the other event. So first let's talk about what the probability that Johnny picks a green marble is. Well, I'm looking at his bag here and I see that there are 1, 2, 3 green marbles. All right, so the number of successful ways to get a green marble is 3 because there's 3 green marbles in there. And then there's a total of count all the marbles. 9 marbles in Johnny's bag. So the probability that Johnny draws a green marble is 3 out of 9, or 3 over 9. Now let's see what the second part means. The probability that Jane does not. Okay, so that means she's not going to draw a green marble. Well, that means she's going to draw, in this case, a blue marble because there's only blue and green marbles in the bag. So she would have to draw a blue marble in order not to draw a green marble. Well, how many blue marbles are in Jane's bag? Let's count them. 1, 2, 3, 4, 5, 6, 7. So there are 7 blue marbles in Jane's bag, still out of a total, in this case, of 10 marbles in her bag. Right? Jane has 10 marbles in her bag. All right, so that means that 8 of them are blue and 2 of them are green. So the chances of drawing a blue marble or not drawing a green marble are 8 out of 10. And then like before, we multiply those probabilities. So we multiply straight across, and 3 times 8 is 24. 9 times 10 is 90. So the chances that this event happens, that Johnny picks a green marble, and then Jane doesn't pick a green marble, is 24 out of 90. And then we can reduce that fraction to 4 out of 15. All right, we could also convert that fraction into a decimal and report the probability as a decimal, or we could report that probability as a percentage, a percent chance that it happens. And so let's take a moment, and after doing that problem, see if you can answer this probability question. All right, so a math class has 2 girls and 2 boys in the 7th grade, and 3 girls and 1 boy in the 8th grade. Okay, so the teacher randomly selects a 7th grader and an 8th grader from the class for a competition. What is the probability that the students she selects are both boys? All right, so we're going to pick one student and then another student, and we're going to find the probability that both of them happen to be boys. All right, so remember, when I solve these problems, the first thing I try to do is try to figure out the total number of outcomes. So how many students are we picking from? That's what you need to decide first. All right, so let's count them up. Well, we have 2 girls here and 2 boys, so there's 4. And then in the other grade we have 3 and 1, so we have 4 plus 3 plus 1. All right, so for a total of 8 students. So between the 7th and the 8th grade, according to this problem, there's only 8 students in this class. All right, now what's the probability that we pick a boy? Well, how many boys are there? So I'm going to count up all the number of boys. That's the number of ways that I could pick a boy, because that's how many boys there are total. All right, so in this case there's 2 in the 7th grade, so there's 2. And then there's only 1 in the 8th, so 2 plus 1 is 3. All right? So the chances that we draw a boy, right, would be 2 out of 4 for the first group, where we have the 4 students here, and 2 of them are boys. Here's the 2 boys. And then we need to draw another teacher, another student from this other class, and we can see here that there are 1, 2, 3 girls, but only 1 boy. All right, so that's only a 1 out of 4 chance. Well, we multiply our probabilities to get 2 out of 16, which reduces to 1 out of 8 chance. As a decimal, that would be 0.125, and as a percentage, that would be 12.5. So there's a 12.5% chance that we randomly select 2 students that are both boys, given this situation. All right, so now that we've practiced finding the probability of independent events, let's practice finding the probability of dependent events. Before that, let's give a definition of what a dependent event is. So if an independent event meant that the outcome of the 2 events do not affect each other, they have no outcomes in common, one doesn't affect the other, then a dependent event means the opposite. It means when we have 2 or more events, the outcomes do affect each other. So what happens in the first event affects the probability or the chances happening in the second event, and so on. All right, so some examples of that would be picking teams for a game of baseball. So let's say we have two captains, right, and we're picking our teams. Well, if the first person picks Johnny, right, then that means the probability of the second person picking Johnny is now 0% because Johnny's already been picked. All right, or if we were looking at a group of boys and girls and we had so many girls and so many boys, and I said, what's the probability that somebody picks a boy and then the next person picks another boy? Well, that would be a depending event because after the first person picked a boy, now there's less boys in the group for the second person to pick. So that changes the probability or the number of outcomes for them, the number of successful outcomes. So another example might be picking two marbles from the same bag without replacement. So key in on this word without replacement because you see that a lot in your checkpoints. So that means I pick a marble, right? I don't put it back in the bag, so I keep it. Then I pick another marble. All right, now depending on what that first marble is I picked, right, it affects the chances of something happening the second pick. So suppose there's only one blue marble in the bag, and on the first pick I just happen to pick that blue marble. Well, then the chances of me picking another blue marble on that second attempt are 0 now because there's no more blue marbles in the bag. And in fact, the total number of marbles in the bag have also changed because now there's one less marble in the bag. I took one out. All right, so let's calculate the probability of some depending events. All right, so look at this example. Suppose Mr. Smith selects 2 students to come to the front of the room. There are 16 students in the class and 10 of them are girls. What is the probability that the first student is a girl and the second student is a boy? All right, so I approach these things separately when I solve this problem. I want to figure out the probability of the first event happening. So the first, what we want to try to do here is select a girl. So I'm going to figure out the total number of ways to select a girl. All right, so that means I need to count the number of girls in the class. Well, it tells us there are 10. All right, there are 10 girls and there are a total of 16 students in the class. All right, so the chances of me picking a girl on that first draw are 10 out of 16. I could pick any one of the 10 girls and there's a total of 16 students in the class. All right, so now let's calculate the probability of the second event. In this case, we want to select a student that's a boy. Well, how many boys are in the class? Well, let's see. There's a total of 16 students. We know 10 of them are girls, so that must mean we have 6 boys. But here's the kicker. Does that mean that the probability of picking a boy on my second pool is 6 out of 16? The answer is no, because I've already pulled one of the students out. I've lined her up. I pulled her to the front of the classroom. So now when I'm picking the boy, there's only 15 students to pick from, right? So that's why the probability of choosing a boy here is 6 out of the remaining 15 students, not 6 out of 16. So you see, when we're calculating these depending events, what it generally affects the most is the total number of outcomes. All right, and so the total number of students to pick from now has gone down by 1 because I've already selected one of the girls from the class. All right, so the probability that we pick a boy is 6 out of 15. There's the total number of boys, and there's the total number of remaining students. And just like we did with independent events, we multiply their probabilities, right? The word "and" means multiply. So remember, when we're trying to find multiple events, calculate the probability of multiple events. What's the probability of this happening and something else happening? That means multiply the probabilities of each individual event. You just got to be careful when you're thinking about what are the probabilities of each individual event happening. So we multiply these two and we get 60 out of 240. Then we can reduce that fraction to 1/4, which means there's a 25% chance that this would happen. right, at random, that I randomly pick a student that's a girl and the second one is a boy. Let's do one more example, then I'll let you try. Suppose a radio disc jockey has 7 songs on this upcoming hour's playlist. All right, so 2 of the songs are rock songs, 2 of the songs are reggae songs, and 3 are country songs. All right, the disc jockey randomly chooses the first song to play, and then she randomly chooses the second song to play from the remaining ones. Right? What is the probability that the first song is a country song and the second song is a reggae song? All right, so I like to start off by thinking about, well, let's see, what do we want to happen first? The first song. Okay, so let's read through again and highlight the important information here. So she's going to choose her first song, and we want that one to be a country song. All right, so here's a list. We can see there's 2 rock, 2 reggae, 3 country. What's the probability that randomly I select a country song? Well, we can see that there are 3 country songs here to choose from, and there is a total of 1, 2, 3, 4, 5, 6, 7 songs total. So the chances of randomly picking a country song are 3 out of 7. So I start there. All right, so now one of these country songs now is off the list. We're not going to play it again. We're not going to play the same song twice in a row. All right, so I'm going to kind of cross this one out. Let's just randomly pick one to cross out. Now we want to calculate the probability that the second song we pick is a reggae song. All right, so remember the total number of ways to pick a reggae song. Well, there's 2 of them here. But now there's only a total of 1, 2, 3, 4, 5, 6 songs remaining. So the probability of choosing the reggae song for the second song is 2 out of 6. And finally, we multiply those probabilities and we get 6 out of 42, which reduces to 1/7. All right, so take a moment to pause the video and let's see if you can find the probability that Dave chooses 2 cards at random from a deck of cards. What is the probability that both cards are aces? So let me give you a little bit of background information because not everybody knows this about a deck of cards, right? In a deck of cards, there are 52 total cards in the deck. All right, and they are cards 2 through ace. Each number of cards has 4. So there are 4 2s, there are 4 3s, there are 4 4s, and so forth. So in this case, we're talking about pulling 2 cards that are both aces, and there's a total number of 4 aces in the deck, and there's a total of 52 cards total. So I'll write that down for you. 52 cards in the deck. 4 aces in the deck. So that's what you need to know to be able to solve this problem. All right. So let's go ahead and calculate the probability of the first event, which is that I pull an ace. All right, so we have to ask ourselves, well, how many aces are in the deck? Okay, well, I just told you that there are 4. So right now there's 4 aces in the deck, and there are 52 total cards in the deck. So the chances of me pulling an ace randomly out of a deck of cards is 4 out of 52. Now let's think about the probability of the second event, which is pulling another ace. Okay, so how many successful outcomes are there when we do that? Is it 4 again? Recall, we already pulled one of the aces out of the deck on our first pull. So now there's only 3 aces left in the deck. How many cards are in the deck? Remember, we just pulled out one of the aces. So there's no longer 52 cards in the deck, there's only 51. So the probability that we pull another ace after we've already pulled an ace out of the deck is 3 out of 51. And then I would multiply those 2 probabilities and get 12 over 2,652, which I can reduce to 1 out of 221. Very small chance, right, that you would randomly pick 2 aces out of a deck. Okay, how about we try this one? Say, the raffle drawing will have 2 winners. One of the entries, 5 people are from Mesa, 2 people are from Gilbert, and 3 people are from Flagstaff. What is the probability that the first winner is from Mesa and the second winner is from Gilbert? Alright, so we're looking at what's the first thing we want to happen? A person from Mesa. Okay, so let's calculate the number of ways, right, to pick a person from Mesa. Well, how many people are from Mesa total? Well, it says 5. How many total people are there altogether? We got 5 here, plus 2 here, plus 3 more here, for a total of 10 people. So the probability of choosing a person at random from Mesa would be then 5 out of 10. Alright, so now we've picked one person from Mesa. We've picked him out. He's 1. Now we got to find the probability that the second winner is from Gilbert. So now how many people am I picking from? How many raffle tickets are left? I already took one out. There were originally 10, so now there's only 9 left in that stack of raffle tickets. Then we got to ask ourselves, well, how many of those are people from Gilbert? Well, originally we picked somebody from Mesa, so there are still 2 people from Gilbert. So I could pick either one of them. 2 out of the remaining 9. So the probability that I pick somebody from Gilbert second is 2 out of 9. We multiply those probabilities to get 8 out of 90, which reduces to 4 out of 45. So one thing I'd like to mention just before I conclude this lesson, right, is to go back to this word here, because you'll see it a lot on your checkpoints, the words replacement and without replacement. Alright, so when you're replacing something, right, then whatever you had retains no memory. So when you're doing something with replacement, that is always an independent event. Alright, so that'd be like if I were playing a game with a deck of cards, and after every single game, I reshuffled. So like say we're playing blackjack, and I deal out a hand, and then I shuffle the deck again, and then I deal another hand. Alright, so the probability of, say, getting a blackjack in the first hand and getting the probability of a blackjack in the second hand are the same, because I reshuffled the cards. So that's an idea of having something with replacement. An example of something to remember without replacement is like the marbles, where I'm taking them out of the bag and keeping them, right? That's a depending event. Or in blackjack, in real life, right, when you're playing blackjack, so we deal, and then the dealer puts those cards aside and continues dealing from the same deck. So he's not replacing those cards. Then what could happen from one hand to the next is dependent. It's dependent on what happened before. So suppose we're playing a game of blackjack, and to get a blackjack you have to have an ace and then a 10. Alright, so suppose we're playing the game of blackjack, and just on the first round, every single ace was played. All 4 aces came out of the deck. Now doesn't that affect your chances of what you can get for the next round? Because we pull those cards now and we set them aside, so now it's impossible to get a blackjack on your second hand because all 4 aces have already been pulled out on the first hand. So it kind of retains a memory. That's another way they say it. Right? So what happens when you have no replacement, right? Or without replacement. That's a depending event. Make sure to go to the course announcements and find the Asynchronous 5 questions, answer the Google form, and submit it.